Hello friends, so now once again let's do an awesome lead code problem that is going to solve all of your problems. So without any delay, let's get started. So the lead code problem we are going to do today is called diameter of a binary tree. We can see that this one is an easy problem and also a very well-liked problem. The problem statement is quite straightforward. We are given the root of a binary tree and we need to return the diameter of the tree. Now the question is, diameter of a tree is the length of the longest path between any two nodes inside this tree, and we are told that this path may or may not pass through the root, but it's gonna pass through the root. Okay. Now the length of the path between any two nodes is represented by the number of edges between them. So let's try to understand that how does a diameter of a tree is being calculated. Let's say that we are given a tree like this. So in this case, what is the longest path we can make? Well, let's just give them the number. So 1, 2, 3, 4 and 5. These are the numbers of this given nodes. So we can see that the longest path over here is this one. So 3, 2, 1 and then 5. This is one path. Second longest path is once again 4, 2, 1 and 5. So in either case, the longest path we are able to make contains three edges. This is going to be the first edge, this or this, either one of them. Then this is the second edge and this is the third edge. So the answer is going to be 3, that this is what we need to return. Now the problem statement is quite easy to understand, but the thing is, how do we actually calculate the diagram? And if we start iterating over every single path and then try to find the answer, then this becomes a lot of complication. So we need to avoid that. And if you look at it from the other way, at any given moment or at any given node, the diameter of that node is nothing but the height on the left hand side. So left hand height and the height on the right hand side. That's it. This is all a diameter is, and we can see that in action over here, that the height on this left subtree is actually going to be 2, because this is the first level and this is the second level, and the height on the right subtree is going to be 1. So if we do 2 plus 1, the answer is going to be 3. So this is what we need to calculate. Now we need to understand that how we are actually going to be able to calculate that for any given binary tree, and for that we simply have to iterate over any given tree, nothing more than that. Now iterating over the tree is actually quite simple, and we can use the common logic of recursion in this problem. Now for recursion, we need two items. First item is a base case. So base case in this case is going to be that if the current node, if that is equal to 0, which means we have reached to the very end and now we cannot go anywhere further. So then we start to do the backtracking. This is the first base case. Now the what is going to be the recursive equation or recursive scenario? Well, recursive scenario is quite simple, that at any given moment or at any given node, the height or the diameter of that node is actually going to be the sum of the left diameter and the sum of the right diameter. And same way, even at subsequent left node, the diameter at that node is going to be sum of the left diameter and right diameter, and that's how we should be able to calculate the answer we are looking for. So in this case, the height on the left hand side is going to be 2. The height on the right hand side is also going to be 2. So the longest path we are going to be able to make is going to be of size 4. And we can also see some examples of that. So one of the longest path starts from this node and then once again to this node, and once again to this node, and then once again to this node, and once again to this node. If we see the number of edges included, this is the first edge, this is the second edge, this is the third edge, and this is the fourth edge. So this is exactly what we are looking for in terms of finding the answer. So we also found out the recursive solution, that the diameter at any given node is going to be the sum of the left node and plus sum of the right node. Okay, and then we can have a recursive function to iteratively call, recursively call our entire tree and then return back the answer. So this is actually going to be the whole solution. We are simply iterating over the tree, calculating the height, and whatever the sum of the height is, we simply return that. If we see time complexity, in this case the time complexity is going to be big O of n, where n is the total number of nodes that are currently present inside the tree, because we will have to iterate over every single node. And in terms of space complexity, well, this is also going to be big O of n, because we are using the recursion, and in order to store the recursive stack, we might use big O of n space. So if you want, you can also do this problem iteratively and in the iterative solution, we actually don't have to do or use the stack. But the only reason I'm using the recursive solution is because it's good to do it like recursively. It's small amount of coding and also looks cool. Okay, so now let's quickly go to the coding. So the coding solution is quite straightforward. We are going to initialize our variable maximum diameter, and we are going to have our method diameter of the tree, from which we are going to call our get height method for left and right subtree for the given root element. Okay, now this our get height method is our recursive method. So let's quickly see what is happening. As a part of the base case, we are having the scenario that if the given node is equal to null, we need to return 0. If that is not the case, then we are going to find the left height and the right height. For both, we are going to recursively call the get height method with the left child and with the right child. Now for every single position, we will have to check that have we reached a new maximum diameter. So for that, we are going to do a simple equation of the current maximum element or maximum diameter we have been able to find. If that is greater, or if we find that the current left and right side subtree's height is greater than the current maximum diameter we have been able to find, then we need to update the max diameter. If that is not the case, then we can simply leave the max diameter as it is. Next, we need to return the height that we have been able to find. So in the end, we are simply going to return 1 plus the maximum value of either left height or the right height. And why are we doing 1 plus? Because at any given root node, we also have to consider the node by itself before propagating the height to its previous level. So that's why this 1 plus is there. Okay, with every new level, basically we add one value to the height. And this is the solution. Let's try to run the code. Okay, seems like our solution is working as expected. Let's submit this code. So our code runs 100% faster than all the other solutions, and that's because the code actually operates on a very simple principle, and it runs in 0 milliseconds. So that's why it's 100% faster. It's nothing magic. Now, once again, the coding solution is present inside our GitHub repository. Let me quickly show it to you that this is the GitHub URL where we have actually stored hundreds of LeetCode questions and their answers. These are some of the most popular questions in the entire world. These questions has been asked at tons of different companies multiple times. So for each of the problem, you can go ahead and see we have the Java file for that. You can go and find the LeetCode link. If you don't find, you can also find the subsequent video solution, and also a list of most asked problems at the FAANG companies, which is this list, which contains a lot of important LeetCode problems. They have been differentiated based on the topics, and for each of the topics I have provided that how many times they have been asked at different top tier IT companies. So there are 130 of most fabulous questions that I have been able to find. Then also I have solved most of the NeetCode 150's problems, and they are also provided over here. So both of these resources are amazing